wireless sensors can monitor how temperature, humidity, or other environmental conditions vary across large swathes of land, such as farms or forests. These tools could provide unique insights for a variety of applications, including digital agriculture and monitoring climate change. One problem, however, is that it is currently time consuming and expensive to physically place hundreds of sensors across a large area. Inspired by how dandelions use the wind to distribute their seeds, a University of Washington team has developed a tiny sensor carrying device that can be blown by the wind as it tumbles toward the ground. This system is about 30 times as heavy as a 1 milligram dandelion seed, but can still travel up to 100 meters in a moderate breeze, about the length of a football field, from where it was released by a drone. Once on the ground, the device, which can hold at least 4 sensors, uses solar panels to power its onboard electronics and can share sensor data up to 60 meters away. The team published these results in the journal Nature. The researcher says that their prototype suggests that we could use a drone to release thousands of these devices in a single drop. They will all be carried by the wind a little differently, and basically we can create a 1,000 device network with this one drop. This is amazing and transformational for the field of deploying sensors, because right now it could take months to manually deploy this many sensors. Because the devices have electronics on board, it is challenging to make the whole system as light as an actual dandelion seed. The first step was to develop a shape that would allow the system to take its time falling to the ground so that it could be tossed around by a breeze. The researchers tested 75 designs to determine what would lead to the smallest terminal velocity, or the maximum speed a device would have as it fell through the air. The way dandelion seed structures work is that they have a central point and these little bristles sticking out to slow down their fall. The researchers took a 2D projection of that to create the base design for their structures. The researchers says that as they added weight, their bristles started to bend inwards. They added a ring structure to make it more stiff and take up more area to help slow it down. To keep things light, the team used solar panels instead of a heavy battery to power the electronics. The devices landed with the solar panels facing upright 90% of the time. Their shape and structure allow them to flip over and fall in a consistently upright orientation similar to a dandelion seed. Without a battery, however, the system can't store a charge, which means that after the sun goes down, the sensors stop working. And then when the sun comes up the next morning, the system needs a bit of energy to get started. The team designed the electronics to include a capacitor, a device that can store some charge overnight. The researchers included a little circuit that will measure how much energy is stored up, and once the sun is up and there is more energy coming in, it will trigger the rest of the system to turn on because it senses that it is above some threshold. These devices use backscatter, a method that involves sending information by reflecting transmitted signals to wirelessly send sensor data back to the researchers. Devices carrying sensors measuring temperature, humidity, pressure, and light sent data until sunset when they turned off. Data collection resumed when the devices turned themselves back on the next morning. To measure how far the devices would travel in the wind, the researchers dropped them from different heights, either by hand or by drone on campus. One trick to spread out the devices from a single drop point is to vary their shapes slightly so they are carried by the breeze differently. Another benefit of the battery-free system is that there is nothing on this device that will run out of juice. The device will keep going until it physically breaks down. One drawback to this is that electronics will be scattered across the ecosystem of interest. The researchers are studying how to make these systems more biodegradable.